Alright, let's look at 7, 10 and 11 here. State and explain the principle of relativity. Principle of relativity states that the laws of the universe are the same in all inertial reference frames. The laws of the universe are the same in all inertial reference frames. Okay, let's look at 10. Someone says to you, momentum isn't a conserved quantity. All I have to do is change to a different inertial reference frame, and the momentum of the system I'm looking at is different from what it was in my first reference frame. How should you respond? Okay, so see if you can answer this question. Try to write something down, try to formulate something in your head. So momentum being conserved means that if you're looking at a system, okay, that's momentum. We're looking at the system momentum now. Momentum being conserved means that the system momentum doesn't change. Okay? So remember that P is mv. So that means that the system or the center of mass velocity doesn't change. Okay? But now if you look at this from another reference frame, inertial reference frame, what's going to happen is this is going to shift down or up depending on your inertial reference frame. So the quantity of your momentum changes in a different reference frame. But conservation of momentum means that delta P is 0. So delta P is 0 in this reference frame, or this reference frame, or this reference frame. Okay? So don't get confused here. Conservation of momentum means that delta P is 0. There's no change in momentum. But if you look at the momentum in different reference frames, then there'll be a different value of or quantity of momentum, but in that reference frame, it doesn't change, right? It stays the same in all of those reference frames. Okay, so that's how you can explain it. All right, 11. Two observers witness an elastic collision from different inertial reference frames. What do they disagree on, and what do they agree on regarding kinetic energy? Okay, so again, always go back to first principles. How do you calculate kinetic energy? Half mv squared, okay? So it's a function of velocity. So remember, we've been going over this again and again. In different inertial reference frames, if that's your velocity time in one reference frame, right, whatever the profile is of your velocity in whatever reference frame, in another inertial reference frame, that velocity profile is just, it's shifted, right, up or down, depending on which object you're looking at. Okay, now all that's happened is that it's shifted. Okay, it's shifted up or down. That's what we need to see with regards to the velocity in another inertial reference frame. So what do they disagree on, looking at it in two different reference frames? Well, they disagree on the kinetic energy, right? Because the velocity in a different reference frame is going to be different. So they disagree on the kinetic energy of each object that collides, and they disagree on the total system kinetic energy. Okay? Does it make sense? So the system and the individual kinetic energies will be different in both reference in the two reference frames, but what they agree on is that in each different reference frame, the total kinetic energy does not change during the collision. Okay? I hope that makes sense. And similarly, for momentum, because the velocity is different in the different reference frames, your momentum, which is a function of velocity, will be different for each object, and the system momentum will be different in the reference frames. But the system momentum, even though it's different in the different reference frames, in both reference frames they agree that the momentum will not change. Momentum is conserved. Okay? Alright, so use my answer together with the answer in the back to hopefully try to understand this.